Assalamu alaikum students, this is the fourth video of chapter number 3 exercise 3.4. In this video I will solve question number 1, part number 13 and part number 14. Moving on to part number 13, it states integral sine inverse x dx. Putting sine inverse x as first and assuming 1 as second function. Integrating by parts we get sine inverse x integral dx negative integral bracket integral dx into derivative of sine inverse x dx. Sine inverse x into x negative integral x into 1 over under root 1 minus x square dx. X sine inverse x plus, as assuming this our function 1 minus x square, taking its derivative we get minus 2x. So multiplying by 2 and dividing by 2 we get 1 over 2 integral 1 minus x square raised to power minus 1 by 2 into negative 2x dx. Now the derivative of this function is present, taking its integral we get x sine inverse x plus 1 over 2 1 minus x square raised to power 1 over 2 over 1 over 2 plus c, which can also be written as x sine inverse x plus under root 1 minus x square plus c. Moving on to part number 14, which is integral x sine inverse x dx. Taking sine inverse x first function and x as second. Integrating by parts we get sine inverse x integral x dx negative integral bracket integral x dx into derivative of sine inverse x dx, which simplifies as sine inverse x into x square over 2 minus integral x square over 2 into 1 over under root 1 minus x square dx. X square sine inverse x over 2 plus, now trying to copy this term in the numerator, we add 1 and subtract 1, and 1 over 2 is also taken as common. So adding and subtracting 1 we get 1 minus x square minus 1, which can be written as x square sine inverse x over 2 plus 1 over 2 integral 1 minus x square, as the same in the denominator dx negative 1 over 2 integral dx over under root 1 minus x square, which can be simplified as x square sine inverse x over 2 plus 1 over 2 integral under root 1 minus x square dx negative 1 over 2 sine inverse x. Now for this integral, this is an inverse function, we have to take its integral. For this we assume this as I is equal to integral under root 1 minus x square dx. Put x is equal to sine theta, which implies theta is equal to sine inverse x. Taking derivative of this function we get dx is equal to cos theta dx. Now putting the values, for this we get dx, putting the values we get integral under root 1 minus sine square theta into cos theta d theta. Sorry, it will be dx is equal to d theta. Integrating we get under root 1 minus sine square theta into cos theta d theta. As we know that 1 minus sine square theta is equal to cos square theta, so putting the value cos square theta into cos theta d theta, this square will be cancelled by under root. It will be written as integral cos theta into cos theta d theta, which can be written as cos square theta d theta. Now we know that cos 2 theta is equal to 2 cos square theta plus 1. Shifting the values we get 2 cos square theta is equal to 1 plus cos 2 theta. 2 is divided on the other side, so we get cos square theta is equal to 1 plus cos 2 theta by 2. Putting the value we get integral 1 plus cos 2 theta by 2 d theta. 1 over 2 is taken as common, so integral 1 plus cos 2 theta into d theta. Taking integral separately we get 1 over 2 integral d theta plus 1 over 2, as we know that the derivative of angle 2 theta is not present, so multiplying and dividing by 2 we get 1 over 2 into 2 integral cos 2 theta into 2 d theta. Integrating we get 1 over 2 theta plus 1 over 4 into 2 sine 2 theta plus c. As we know that sine 2 theta is equal to 2 sine theta cos theta. Putting the value we get 1 over 2 theta plus 1 over 4 dot 2 sine theta cos theta plus c. 2 is cancelled by this 4, so it will be written as 1 over 2 sine inverse, putting the values from here sin inverse x plus 1 over 2 x under root cos square theta plus c. 1 over 2 sin inverse x plus 1 over 2 x 1 minus sin square theta plus c, which can be written as I is equal to 1 over 2 sin inverse x plus 1 over 2 x under root 1 minus x square plus c. Now putting the value of this which we have calculated here we get x square sin inverse x over 2 plus 1 over 2 bracket 1 over 2 sin inverse x plus 1 over 2 x into 1 minus x square bracket of minus 1 over 2 sin inverse x plus c, which can be simplified as x square sin inverse x over 2 plus 1 over 4 sin inverse x plus x into 1 minus x square under root over 4 minus 1 over 2 sin inverse x plus c, which can be simplified as x square sin inverse x over 2 negative 1 over 4 sin inverse x plus x into under root 1 minus x square over 4 plus c.